Good morning, kids. Today we're going to look at the second part of that note sheet that you received last class on derivatives of hyperbolic trig functions. These are your 6 basic hyperbolic trig functions. Now, the funny thing about this is they are not sines and cosines. They are what we call sinh. The way we would pronounce this is sinh. This is cosh. This is tanch. This is cotanch. And then secant and cosecant. So it's a hyperbolic trig function. Now what that is it's basically various manipulations of e to the x which behave very much like trig functions when you take their derivatives. So, and they have similar identities. It's really kind of crazy. All right, so this is what they look like. Do you need to know what they look like? Well, I'm sure you'll be happy to know that no, you do not need to know exactly what they look like. You can always graph them if you need to know what they look like. These are the identities for hyperbolic trig functions. They are very similar, yet not exactly the same as the trig function identities. And then we have derivatives of hyperbolic trig functions, which we are going to be responsible for. And then we have derivatives of inverse hyperbolic trig functions, which your nice old lady math teacher is not going to hold you responsible for those. So really, all of this information is here, but the ones that you really need to know are in this box. So put a circle around them. These are the derivatives of the hyperbolic trig functions. Now, the cool thing is they behave, for the most part, just like the derivatives of the regular trig functions. Derivative of sine is cosine. The derivative of sine is cosine, the derivative of sinh is cosh. All right, so this one behaves the same way. The derivative of tanch, you notice I skipped the cosh and I'm going down to tanch. Derivative of tanch is secant squared, which is the same as with tangent and secant squared. The derivative of cotangent, wow, this is tongue twister stuff, is negative cosecant squared of the variable. I haven't been saying the variable afterwards. I should be. So that's another one that's the same. And then finally, the derivative of cosecant is negative cosecant of the variable, cotanch of the variable. All right, so that's the same as cosecant. The two that are different are derivative of cosh and the derivative of secant, which should make sense because secant is the reciprocal function of cosh. All right, so those two are slightly different, although they're not that different. They only differ by a sign, by a negative sign. So the derivative of cosh is sinh. All right, instead of, so when you're doing derivatives of sinh and cosh, you don't have to worry about negative signs. All right, and then the derivative of secant is normally, the derivative of secant is normally secant of the variable, tan of the variable. The derivative of secant of the variable is equal to negative secant of the variable, tan of the variable. All right, so it's just slightly different. And that is it. Now, you could just put an x after these and not have the du dx, right? This is just shows the du dx afterwards means if you have something other than the plain variable inside, you have to take the derivative of the inside of the function. That's all the du dx is showing you in those. So you can just drop that off the end if you need to. All right, so we're going to do some of these, just a few, and then I'm going to be done with you for the day. I'm hoping that, did I? Yes. The assignment, I think these are the hyperbolic ones, page 234 to 235, 13 to 29 odd. should be the hyperbolic ones. If not, it's back there on 225. As I said last time, I'm not sure which is which, and my lack of a book is really proving to be a hindrance, particularly with my Calc 2 lecture today. It was really ugly. So let's see how this goes. This should be fine. So the derivative of sinh of something is cosh of that same thing, and then you have to take the derivative of the inside. So y prime here is equal to 1/2 cosh of 2x plus 1. Remember, you never change the inside. And then multiply by the derivative of the inside, which is 2. And then, of course, our 2's will cancel. Bang, bang. And we get y prime is equal to cosh of 2x plus 1. Done. That one was easy. Someone should push the easy button on my desk. Whoa. I've had all sorts of technical difficulties today. Y equals t squared tanh 1/t. Now, the thing that should pop out at you here is you're going to have to do a product rule, but other than that, it's not really any different. So let's just do our product rule. Y prime equals second function, tanh of 1/t, times the derivative of the first function, which is 2t, plus the first function, t squared, times the derivative of the second function, which the derivative of tanh is secant squared of whatever's inside there, so 1/t. And then we have to do the derivative of 1/t. Derivative of 1/t, that's t to the negative 1, so when we take its derivative, it's negative t to the negative 2. So now we'll just simplify. Remember that thing that's inside the function, the trig function, can never be moved. So I get 2t tanh of 1/t. It's negative on the t squared, t to the negative 2 here. Alright, so I get minus. Now, t to the negative 2, that's 1/t squared. Alright, so 1/t squared times t squared will cancel each other and give you a 1. So you just end up with minus secant squared of 1/t. And that one's done. Next, y equals the natural log of the cosh of x. So let's do this one. So we get y prime equals, to take the derivative of a natural log function, it's 1 over whatever's inside. So this is going to be 1 over cosh of x times the derivative of the inside. Well, the derivative of the inside is sinh of x. So what we have here is y prime is equal to sinh of x over cosh of x. Now, let's go to the page before, double check. Maybe. Whoa. Oh, I hate when that happens. It's skipping all over the place. I guess I'll have to go slowly to the page before because my computer is not happy with all of the tasks I'm asking it to perform right now. Oh dear. Sure is slow. So, how's everybody doing? How's your day going? Oh, Miss Mary is getting so beautiful. She just, I had professional shots done of her yesterday, and man, I just can't believe how gorgeous they turned out. So, oops, let's see here. Tanh is equal to sinh over cosh. You can see it right there. It just buzzed by. There it is, right there. Tanh equals sinh over cosh. So, we can just replace the sinh over cosh with the tanh. Oh, there were 5 problems. I thought there was just 4. Next one, really quite ugly. I might try to use an identity on this. I bet there's some sort of identity up there on the page before that applies to this. Oh, no, No, it doesn't, because you have a natural log there. So let's go ahead and just do the problem. We have a product here. So this is the first, and this is the second function. So we say y prime is equal to the second function, 1 minus the natural log of cosecant of theta times the derivative of the first function. The derivative of cosecant of theta is negative cosecant of theta times, oops, forgot my h. This would really be quick today if my computer worked. Times cotangent of theta. Alright, so we have that, and then plus the derivative of, the first function times the derivative of the second function. So let me slide all of this over. So the first function is cosecant of theta times the derivative of the second function. Derivative of 1 is 0, and then the derivative of negative natural log of cosecant of theta is negative 1 over cosecant of theta, and then times the derivative of the inside, and the derivative of the inside is negative cosecant of theta cotangent of theta. And again, I'm running out of space, so I'm going to have to shrink this up or something. Wow, it's thinking really hard. Alright, so that's the whole thing. Now we can do some simplification here, of course. Not a lot. This first thing is very ugly, and there's really not a whole lot we can do with that, so I'm not going to touch it. The second thing, what we can do is we can cancel this negative cosecant of theta with this negative 1 over cosecant of theta. So all we get is cosecant of theta, cotangent of theta there. Alright, so y prime, and Mary is waking up, of course, is equal to, now it's funny because you have that factor now in both parts. You see you have a cosecant of theta, cotangent of theta here, and you have a cosecant of theta, cotangent of theta here. So I'm going to factor that out of both parts, because if I do, I think I get something a little simpler. So let me try. So if I take the negative, I'm not going to factor it out as a negative. I'm just, let's see here. Should I factor out as a negative? Sure, I'll factor it out as a negative. Negative cosecant of theta, cotangent of theta. If I factor it out of this first thing, what I'm left with inside is 1 minus natural log of cosecant of theta. And then if I factor that negative cosecant cotangent out of the second thing, I get minus 1. See how that works? So that's handy, because what happens is the 1's will eliminate each other. I have a 1 and a minus 1. So now, basically, I have y prime equals negative cosecant theta cotangent theta times negative natural log of cosecant of theta. But I don't need the negative, because two negatives will give me a positive. So times natural log of cosecant of theta. So that is much simplified, and we're done with that one now. So I think you have an idea of what's going on here now. Let me try to get to the bottom of the page here. There we go. As I said, I'm not going to hold you responsible for the inverse trig functions, so I'm not even going to bother with this one, although it would be fairly easy to do. In the interest of time, I'm not going to, so this is your homework, the hyperbolic homework, and have a fabulous day. We are almost to the end of my leave, which makes me both happy and sad at the same time. Happy because I'll get to see you, sad because I won't get to see Mary, but life is good either way. Have a great day, kids.